Good day once again, and welcome to Lesson 3. In Lesson 3, we'll be looking at lubricants and lubrication. My name is Engineer Sonny Ogboji, and I'll be taking us through different aspects of lubrication and the issue of lubricants. First and foremost, what is lubrication? Lubrication is the control of friction and wear by the introduction of a friction-reducing film called a lubricant between moving surfaces in contact. Each time two solid surfaces move relative to one another, there is friction. Friction is the force that opposes the relative motion between these two surfaces. And as a result of friction, there is wear or a gradual eating up of the surfaces. And also there is heat that is generated. Friction has its own advantages, and there are applications where we take advantage of frictional force. But in most applications, friction is a disadvantage, and we want to keep it at the barest minimum, if not eliminating it completely. And that is why the issue of lubrication comes up. The lubricant used can be either a fluid, a solid, or a plastic substance. What are the objectives of lubrication? The primary objectives of lubrication are to reduce frictional resistance, bring friction to the barest minimum. If at all, you cannot completely eliminate it. Number two, to reduce wear on the operating and other surfaces. Prolonged wear will reduce the size, the dimensions of the surfaces in contact, and sometimes, especially for where you are talking about equipment that wear size matters. Wear size and specifications matter. It could become an issue. So we want to make sure that we reduce the rate of wear to the barest minimum. The third objective of lubrication is to protect the equipment from corrosion. Corrosion is a very big issue in engineering, especially when you're dealing with metals, and we want to keep it far away from us as much as possible. So we protect by lubricating. The lubricant forms a coating, and to make sure that all the component parts or the ingredients required for corrosion to take place are not complete again, thereby stalling corrosion. Another objective of lubrication is what? Is to control temperature. Lubrication helps to dissipate heat. Heat that is generated at the contacting surfaces is taken away, and by that, the surfaces or the environment is made cool or is kept at relatively cool temperatures. Another objective is to control contamination. Lubricants carry contaminants to a filter or a sump, and the contaminants so carried are moved away from the place where they could affect the surfaces in contact. Then another objective of lubrication is to transmit power. This takes place in hydraulics, where we use fluid power to be able to do work or to accomplish several tasks. Transmission of power is one of the objectives of lubrication. Then also the lubricant can provide a fluid seal that seals off surfaces and prevents some leakage, like we have in some high-tech shock absorbers and some other components. It provides a very tight seal that prevents some form of leakage. And lastly, lubrication has as one of its objectives the reduction of noise from moving components. This is called dampening. A lubricant can actually serve as a damper, and that can help in reduction of noise from the contacting surfaces. What are the features of the different lubricant types that we have? Lubricants that are considered good or high quality will normally possess the following properties. Now I want to take time to explain some of these properties enough. The first thing is that every good lubricant must have a high boiling point. The boiling point is the point at which a liquid or a gas begins to boil as it changes from the liquid state into the gaseous state. At that state, it is no longer stable. So if you have a substance or a material that you're using as a lubricant, the boiling point has to be very, very high, so that it doesn't matter the temperature that is generated within that system or the subsystem where it is located or where it is doing the work of a lubricant, the temperature cannot heat it up to a point where it begins to boil and converts to the gaseous stage. So the first thing is high boiling point. Then a lubricant must have low freezing point so that it does not get frozen. Because when it gets frozen, it will affect its ability to circulate around the different parts of the machinery where it is supposed to provide lubricating action. So it must have very low freezing point. The next one is high viscosity index. Viscosity index refers to the degree of internal resistance to flow of the molecules of the lubricant to flow. And the viscosity index must be very, very high for a good lubricant. What it means is that if you drop a drop of that lubricant here, it should be able to hold its own and not be able to flow away immediately. If it flows, if the viscosity index is low, what it means is that as you are dropping that lubricant, it just vanishes into thin air, leaving the surfaces dry, and then they can easily make contact, and the problem is not solved. Then a lubricant must have what we call thermal stability. It doesn't matter the variations in temperature or how high the temperature, it should be able to remain thermally stable, as all the properties required as accounted for by the additives and the components of that lubricant must stay intact for as long as possible, and there must be no deterioration in the chemical composition or the properties, the mechanical properties, the physical properties of that lubricant as it applies to functioning under a heated environment. It must have hydraulic stability. It must be stable as a hydraulic medium, hydraulic fluid, and operate well under that condition over a good interval of time. Then it must have ability to prevent corrosion, ability to prevent rust or degradation of material as a result of what? Corrosion. And then it must be highly resistant to oxidation. It must not permit easy oxidation, because oxidation will be inimical. It will be very, very counterproductive for the environment where the lubricant is required to function. Having looked at these properties, the next big question is, what are the criteria we use when selecting our lubricants? What and what do we consider when we want to select the kind of lubricant we want to use to provide lubricating functions? The truth is, there are so many options on the shelves. If you go out to stores, you want to get lubricant, there are so many options. New ones are being churned out every day. So what and what do I consider when I want to go shopping for a lubricant to serve me and to give me the desired performance I am looking for? The first thing is, I should look at the function of that the lubricant is expected to perform. That's the first factor that comes to mind. What is the function that this particular lubricant I am looking for is expected to perform? Lubricants reduce heat generation and energy consumption due to friction. Lubricants can reduce mechanical and corrosive wear. Lubricants protect surfaces from corrosion and corrosive substances. Lubricants transport particles and other contaminants to filters and separators. Lubricants can absorb and transfer heat. And then lubricants can serve for power transmission. All these are the functions that a good lubricant is meant to perform. So depending on the need at the point of application, I want to watch out for the composition of that particular lubricant that I am about buying or about using. Can it provide all these services? If it cannot, then I look for an alternative. The next factor that I consider when selecting lubricant is the content of the lubricant. Lubricants contain many ingredients called additives. Essentially, a lubricant is made up of what? Base oil and additives. It is the additives that supply all the different properties that empowers a lubricant to be able to carry out all these functions. The function of dampening, the function of increasing the base number, the function of increasing the pour point, and the flash point, and all those other things. It is the additives that account for those ones. inhibiting oxidation, inhibiting or dampening. All these are accounted for by the additives that are introduced in any particular kind of lubricant. So they contain many ingredients called additives in addition to the base oil. These ingredients are deliberately chosen based on the intended application for the lubricant. Criteria number 3 in selection of lubricants. Other qualities and performance criteria that I need to watch out for when I'm trying to select my lubricant. And the most commonly used terms include what? In performance criteria include kinematic viscosity, which is a measure of the internal resistance to flow. Like I explained earlier, you drop a drop of the lubricant here and you watch. If it has a high kinematic viscosity, it means the molecules are able to hold themselves together. High adhesive force exists between them, or cohesive force, I mean, and they will not just flow or start flowing and then disappear from that place. So the kinematic viscosity has to be very, very high. The next thing is the weight. This also relates to how viscous the oil is or how easily it will begin to flow at specific temperature. Essentially, for some applications, we need oils with high viscosity, and for some other applications and for some other environment, we might not need too high a viscosity level. So it depends on the point of application. The next thing in quality and performance criteria is what? The NLGI consistency. NLGI stands for National Lubrication and Grease Institute of America, and they've been able to come up with a code, a graduation that tells us how consistent different classes of lubricants, especially greases, will be, and they are represented by specific numbers. They indicate how hard or soft the grease is going to be. The numbers range from 000 to 6 on the scale developed by that institute, the NLGI. And for different applications, you can pick specific grease types of corresponding NLGI ratings and use them for your applications. Then runout. This term refers to the ability of a grease or oil to resist higher temperatures, which tend to make lubricants less viscous. I want to check what is the runout level for this particular lubricant that I want to use. And lastly, the shear stability. This is the resistance of the oil to a change in viscosity caused by mechanical stress. You know, as the oil or the lubricant is subjected to mechanical stress from the operating environment, there's the tendency that it will begin to experience a change in viscosity. And a good lubricant should be able to resist this change of viscosity that is occasioned by the mechanical stress from that environment. We're also interested in that. The fourth criteria for selection of lubricant is the ease of application. The ease of application. And what we mean by ease of application is that the method of application will depend on the particular environment. Where you have an easy-to-reach hinge, you can use something like an easy-to-reach hinge or something that is externally exposed. It doesn't take any serious effort to get to the location of the equipment. You can use things like an aerosol lubricant to carry out your lubrication. Grease may be easily applied by hand to an accessible gearbox, where you have a gear drive or a drivetrain where the gears are exposed externally and it does not take anything to be able to reach them. If we apply grease, the grease will stay there, and as the gears rotate, as the drive rotate, your grease will serve its purpose. But when you have a case where you have a hard-to-reach location on a particular machine, you need to dismantle and loose covers and isolate one or two components before you get to your desired location, then it becomes a more serious issue. You might need an automatic dispenser as your best option that will automatically dispense the lubricant, and you may not need to be opening and closing to get to that location. What if I have a case where I am using chains? For a chain drive, you might need a continuous dispenser, because as long as you're operating, the chains continue to move, and as they are moving, if you just apply lubricant and you go away, with time, that lubricant gets used, it gets spent, and the chains become dry again. So you need an arrangement where there's a continuous feed, intermittent feed of lubricant to keep the chain well lubricated. So ease of application is a very serious factor. You want to go for lubricants that will be the easiest to apply depending on the nature, the design of your equipment or where you want to lubricate. The fifth criterion is what? Longevity. Lubricants have an optimal lifespan, and once it's over, they need to be replaced. Failure to do so can result in runout, metal-on-metal contact, damaged bearings, and other issues. Something we look at that comes to mind when we are talking about the lifespan of a lubricant, for instance, I want to talk about the total base number. Initially, when you buy your lubricant or at the point of application, maybe after servicing or whatever, and you're applying it for the first time, the base number, the total base number is at the highest level. And the total base number is what? The degree of the inherent power in the lubricant to neutralize the acid generating effect as a result of oxidation. So the total base number is highest when the lubricant is new. Now, as you continue to use the lubricant, especially dependent on the environment, oxidation begins to take place. Now, the lubricant will begin to fight oxidation, and as it continues to fight oxidation, the total base number reduces until it gets to zero level. Once it's at zero level, that lubricant is spent. It doesn't matter how fresh it's still looking, you need to change it, because failure to do that, it means that oxidation will just have a free way and begin to happen in the course of the machine, and other damages that are related to oxidation will begin to show up. So we need the total base number. How do I know that I have oxidation problems in my machinery? When you discover, for instance, that at the point of servicing or where you want to drain out and change that oil or whatever, it is thicker than it was when you installed it at first, it means oxidation is taking place in that oil already. Where you see symptoms like foaming and the rest. And lastly, the cost. The price tag on the container, the cost of downtime or replacement, loss of products due to halted production, and employee hours, all these are costs associated with lubricants. And want to be careful that we go for lubricants that are pocket-friendly but very, very effective and efficient as means of lubrication. Now, what are the lubrication techniques that are available? The lubrication techniques, the four most common methods used to supply lubrication to machine parts are the oil drip feed lubrication, the oil splash feed lubrication, oil force feed lubrication, and then lubrication by means of grease. The oil drip feed lubrication, as the name implies, is where you have an arrangement or a system where your lubricating oil is allowed to drop, to drip, comes in form of drop, and it falls on the surfaces that need to be lubricated, and it could be well timed. You could use timers to time the rate of discharge. So as the system continues to run, as the drives continue to run, you see the oil dropping on it, and then it lubricates. And there must also be a system where the oil that is used can be collected and reintroduced into the reservoir, from where they can allow to flow through the lines and they can drop again on the parts. Then the next one is the oil splash feed lubrication. Here, you have an arrangement where there is a kind of sump or an oil reservoir where your oil is contained, and then some part of the drive or the machinery is allowed to dip into the sump while operating. And as they operate, when they make contact with the oil in the sump, they scoop some oil, and then as they operate, it can fall and splash. And the splashing effect ensures that all other parts of the drive, all other parts of the equipment that are not in contact with the oil in the reservoir are lubricated as a result of the splashing action of the lube, of the lubricant. The third one is the oil force feed lubrication. Here you use pumps to be able to forcefully send your oil to the point of application, and then they are ejected on the surfaces. And of course, There's also an arrangement for recycling where every oil that is used is collected and returned back to your reservoir, from where your pumping action can ensure that they go back again to the point of use. And so it continues to circulate. And lastly, we have grease. Grease, for most of the applications, is manually applied. Here, you just scoop the grease. After cleaning the surfaces, you apply them, and then you cover them with the grease, and then you can cover up your surfaces again. And for grease, we can use things like the grease gun that helps you to be able to extrude the grease with some force out of the gun into your ZEC fittings, where they go into the material at the point of need. Or where you have plumber blocks, you have bearing housing, you can actually lose them, clean the surfaces, apply the grease manually, lock them again, and you are good to go in terms of your equipment. So we can either use drip feed lubrication, splash feed lubrication, force feed lubrication, or grease lubrication. These are the four predominantly popular methods of application of lubricant. So under lesson 3, we'll be able to define lubricants and lubrication. We're going to look at the properties of lubricants. We're going to look at the objectives of lubrication, why we need to carry out lubrication. We have looked at the features and then the criteria that we use to select lubricants. And lastly, we looked at the methods that you use in applying lubricants at the point of need so that the surfaces can stay protected, which we say are four mainly: the drip, the splash, the force feed, and the grease lubrication. Thank you very much.